Hello. Today, we are going to confirm about the concept of storage organization. For example, consider any languages like C, C++, Java as such. Whenever we save the program, then that program will be saved in the hard disk, so during compilation also program stores in the hard disk only, but the CPU or a processor cannot execute a program if it is in a hard disk to present in main memory only. For that reason, after the compilation process, the compiler demands a block of memory from that operating system to store the program in the main memory. So by demanding the operating system provides a main memory. So, a CPU or a processor can execute the program. Let's raise a question here. Why is it reminding the operating system? Because the operating system is responsible for managing resources such as processors, memory files. So, the compiler must organize the runtime memory to represent data objects that are manipulated by the source code. So after being manipulated by the source code, those data objects are stored in a particular organization. For such an organization, compiler uses the runtime memory. So the runtime memory has four parts. They are code, static data, stack, heap. So using these four blocks, the code which is manipulated contains data objects. Those data objects are stored in this runtime memory. So first, coming to the first block, that is target code. This area contains target executable code. During the compilation process, the size of the code is decided. Next, coming to the static data, which is the second block. Generally static means fixed or stationary. Suppose, take an example, a car remains at only one place for such a long time. So here we can consider that the car is in a fixed position or a stationary position. So static data means the data is fixed based on the size of data, because the size of the data is already known and compiled. So the fixed data objects are located in this area. The data can be local variables and also global variables. Next, coming heap. It is a memory area used by programming languages like C, C++, or Java to store global variables. So, all global variables are stored in heap memory space. Heap supports dynamic memory allocation. Dynamic means the constant charge or motion. For example, a car is continuously moving and changing its route using Google Maps. Next, coming to another topic, is stack. Stack is a storage area that stores information in such a way that the last item is stored as the first item to retrieve LIFO, which is last in first out. Let's consider an example for a stack that consists of A, B, C, where A is stored first, then B, then C. Now if you want to remove an element from the stack, initially, we need to remove the C, because it has been stacked lastly. So at first, we have to remove it, then later we have to remove B, then next we have to remove A. Here we can say this is the best example for last in first out. So basically stack holds the address of the top of the element. So the stack is used to store the activation records information. Basically, when a function or program of the procedure is called, an activation record is created. To store the information of the activation record, the stack is used. So stack contains two operations, push and pop, where push is used to insert an item on the top of the stack and pop is used to delete an item from the top of the stack. Next, activation record. So whenever a function or procedure is called, an activation record gets created and pushed into the stack. Activation record is used to manage the information needed by a single execution of a procedure or function. Here we can see the model of activation record. The next topic is the calling function. When you define a function, you give a name to a set of actions that you want the computer to perform. When you call a function, you are telling the computer to run or execute the set of actions. For example, so, here to draw a long line, we are calling a long line function. By this we will draw a long line function. Next, return value. It is used by calling a function to return a value to the called function. It stores the result of a function call. Next, actual parameters. The parameter is nothing but a variable that is defined during function or definition. Example. It is used by calling functions to supply or possible parameters to the called function. Example. Next, control link. It points to the activation record of calling functions. For example, inside these add functions we are defining another function that is a sub-function. Here add is a calling function, and subtraction function is a called function. Next, access link. It is used to refer to non-local data which are stored in other activation records. Next, saved machine status. It stores the address of the next instruction to be executed. Next. Local data. These are local variables that are the variables which are declared inside a function. Example, here, scope of this variable is within main function only. Therefore called local to main function. Next. Temporaries. These are nothing but temp variables. To evaluate an expression, temp variables are used. Example, well, that's the end of today's topic. Along with the video explanations, we offer notes, mind maps, infographics and more to all the subjects from your syllabus. And also career guidance programs from current working IT professionals. And many more to our supporters. To join our supporters community, use the subscription link given below. For more topics from your syllabus, please visit our website given in the description. If you like the explanation, press the like button and rate us from 1 to 5 in the comments section below. For getting updates on any video we posted, please subscribe to our channel and press the bell icon. We will be back with another concept soon.